it helps us find what's interesting for you. So about me, your presenter, Bert Laverman. I'm a software architect and developer at AxonIQ. And today we're going to talk about Running Axon Server. We're going to discuss the environment. I'll tell you a bit about what I'm using here to show you about Running Axon Server. Then we're going into AxonServer configuration and how to deal with storage. We're going to move to Kubernetes and then also discuss AxonServer Enterprise Edition, what this brings to the table. And then depending on how much time left, we can also touch upon Helm, which is a popular tool used for installing applications on Kubernetes, and discuss a basic Helm chart that we have available. And at the end, some time for questions. So what I'm going to use here, of course, the AxonServer jars. If you haven't downloaded it, please go to this download link shown here. You get a zip file complete with AxonServer and all the jars of the Axon framework. There is also a repository on GitHub with all the scripts that you might want to use to run AxonServer locally, run it in Docker. All the deployment descriptors for Kubernetes are there, and the Helm chart is in there. Then we're running this with Java 11, although AxonServer itself is compiled in mode for Java 8. We, of course, use the long time supported version 11. And in the first runs, we're going to run in Docker and then in Kubernetes. If you want to do this yourself, Minikube will work fine, or Docker Desktop, which is probably the most used with Windows and macOS. And for Helm, we're using version 3. And I included here the link. So all the examples that I'm going to show you will be shell scripts or shell commands in Unix form. Bash will work fine. ZSH is what I'm using at the moment. On Linux, just install Docker and get Minikube. macOS and Windows 10, my advice is simply to use Docker Desktop with Kubernetes installed. It's very easy and works fine, although for Windows, there is the difference. If you are lucky enough that you already have built 2004, then I strongly suggest you enable the the Windows subsystem for Linux version 2 and use the Docker engine based on WSL2, because it definitely brings the best implementation for Docker on Windows at the moment. If you don't have it yet, you can use it perfect for AxonServer. Just remember that some of the volume mapping options will not always work as predicted, especially if you're using tools like Sigwin or Ming, the minimalistic Windows GNU implementation. We're also not going to go into too much detail about the Axon framework itself, CQRS event sourcing. There are trainings and also webinars for that. There is a free training online. So please look at the URL shown here for the next available training and use that if you want to dive into that subject. We're also not going to dive into the details of tuning the AxonServer connector. There's a lot you can do there on the AxonServer side as well as on the client side. Please see the reference guide for more information. And I'll tell a lot about how Docker and Kubernetes behave with respect to AxonServer, but I'm going to assume you know at least a little bit about it. So let's go for the first start of AxonServer. Most important thing to know when you start running AxonServer is that AxonServer uses 2 ports. in the standard edition, port 8024 is used for HTTP, and it exposes the web UI and also a REST interface. We'll show that in the demo. The second port is 8124, which is used for gRPC connections. This is what the Axon framework clients connect to. AxonServer itself will provide both messaging and event store support. The messaging has to do with the situation where you have several client applications connecting to AxonServer, and AxonServer will send the messages to the correct destination. The event store is, of course, for the event sourcing. All events are stored there and written back when you use event trackers. To understand how it behaves, let's just run it. So let's go to the terminal. Here I'm using some of the scripts that are also in the GitHub repository, but first for Docker, just go to an empty directory. AxonServer Standard Edition is available on Docker Hub. So first we're going to make sure that we have the latest version and pull axonic/AxonServer. And now we can run it. I'm going to use a few options here, -D to run it in the background. I'm adding RM to make sure that it cleans up as soon as it's stopped. I'm going to give it a useful name so I don't have to guess what Docker has found for us. And of course, we have the ports that need to be exposed. Finish off with the name of the image. And let me see, space here. Like this. So we can use the docker logs command, of course, to check how things are progressing. In this case, here you see AxonServer Standard Edition. This is the latest and greatest release, 4.4. It is starting up. It tells us that it's now using the default situation, which means no SSL and no access control. You can run this a second time just to make sure, but if you see this message, started AxonServer, then you know that AxonServer is ready. And now we can talk to it using HTTP. Now, for this first example, I'm going to use curl to the HTTP port and then go to the REST API, which is under /v1, using a tool called JQ for some pretty printing and a little bit of colors. And here you see AxonServer telling about itself. We already said access control is disabled, so authentication false, clustered is false, it's just a single node instance. SSL false. This is an admin node. Admin nodes are something that especially crops up if you're using the Enterprise Edition clusters, but basically it means that you can administer everything about a group of nodes together. Development mode false. You can start AxonServer in development mode, which allows you to clear the event store while it is running without having to stop it. That might be useful if you're doing testing or local development. We see there is a single context here named default, because Standard Edition only supports a single context. This will always be called default. And then we have the two ports, the HTTP port and the gRPC port. The internal host name with a almost unreadable null behind it and the internal port, those are only used for clusters with Enterprise Edition. And the last two entries, the name of this node, a very useful randomly generated name that comes from Docker, with of course the host name the same. The second thing I can do here is go to the browser and then go to the same port and here you get the same kind of information, status about the last event, -1, there is no event in here yet. And this is standard edition. Overview will tell us nothing more than that it's a node with this randomly generated name. And of course, what will be important later on, there is a tab where you can add users. Now we're not going to do much more here, but we're going to run a small test application. This test application is also available in the GitHub repository, Running Axon Server. It's a small tester, and we're going to use a few test settings. I'll show you the settings, but these are environment variables. The first one is a Spring profile that tells the test program it should connect to AxonServer. The second one says that it should only wait for 2 seconds at the end of the run to see if any more events are in there. And we do some logging level settings here as well. So let's run the test program. And you see the only important lines here for this test run. We have a single command which was sent by the demo with a message saying hi there, and that caused a single event with the same timestamp. If I run this program a second time, what you'll notice is that we now get 2 events. Here. And this is of course the effect of the event store. The first event was stored there, and the second run, the event handler got a replay of all existing messages before the newest was added. Now, let's go back to the slides. This was a very simple run. In the slides, I give the commands that I have used so you can replay it yourself. The slides will be distributed also. So for configuration, AxonServer uses a properties file. It is itself a Spring Boot application. If you're familiar with Java programming and Spring Boot, then you know that it's usually a file called application.properties or application.yaml. For AxonServer, it's been renamed to AxonServer.yaml or .properties. And it also allows this file to be located in a subdirectory called config. Then there are further options that you can pass if you run AxonServer locally with java -jar AxonServer.jar by adding the -d option with properties and additional values. The properties can also be passed as environment variables that I showed you with the settings I used myself, as long as you translate all the property names in uppercase and use underscores for any dash in the name or for any camel case switch between lowercase and uppercase. Then on Docker Hub, the image we have there AxonServer is installed in the root of the container. The configuration, the default configuration, is also in a file in the root as a properties file. And I've shown the contents of this default file here. It sets the storage for the event store and snapshots in /event data, and the control database, which is a small database used by AxonServer to keep the configuration information in a directory called /data. There is also a processor ID file generated and placed in the same location. Then last, the log file is also put to the same location. So if we now add a volume for this directory, that means we can access the log file, even though it's running in Docker. So what you usually do for configuration is dependent on the directory where AxonServer is running, and in this case, AxonServer is running in the root, is that you use the common settings in a file AxonServer properties or YAML in that same location, which has been done for the standard editions image on Docker Hub. And then you can use the subdirectory config for any specific overrides. We're going to use that in the next example. The -d or the environment variables are best used for one-time settings or overrides for specific situations. For example, if you want to make use of that development mode, then that is the kind of thing that you would put in an environment variable. There is also a license file for AxonServer Enterprise Edition. And for version 4.3, the only way to change the location of that license file is using an environment variable. With 4.4, we introduced a property for the location of this file. Added a note here, it is a Spring Boot application. So if you want to do things like set Spring profiles, make sure that you use the -d option before the -jar or environment variables. If a client connects to AxonServer, the client uses a property called axon.axonserver.servers. Default value is localhost. So in this case, our quick tester, it was told to connect to AxonServer, but it was not told where AxonServer was. It used the default localhost. Also, the default is to use the port 8124. If access control is enabled, we need to add a token, and that is done using the AxonServer token property. Then in the case of AxonServer Enterprise Edition, where you have or can have a cluster, AxonServer may respond to the client with a request to connect to another node in the cluster. This is of course for things like load balancing, but it might also be because of tags set on the client and on the server. If you have a cluster with different nodes in different regions, you could ask give the client tags to ask AxonServer for the node closest to it. So let's go back to AxonServer in Docker and start using those volumes. Sorry. So let's stop the current AxonServer instance. Now in this directory currently there is nothing. So I'm going to make here a config directory, a data directory, and an events directory. And in the config directory, I'm going to put a properties file which I'm going to use to set the name of this AxonServer instance to AxonServer. like this. And because we want to make sure that since AxonServer itself is running in Docker, and we don't want to run the risk of any redirects to a randomly generated host name, we want to make sure that it announces itself as using hostname localhost. So it looks like this. Now we're going to start AxonServer. And again, the same option, run in the background, clean up after stop, name AxonServer, the same 2 ports, but now I add a volume mapping. This has to be a full path name, and I let it refer to the config directory I made here and map that to /config. For data also /data, and the directory here called events is mapped to /event data. So let's start AxonServer. And let's wait until it has started. Okay. Now if I go back to the REST API, you now see that the name is given as AxonServer, just as we specified. Host name is specified as localhost. Also, if we take a look at the directories here, you see that there are now files in the data and events directory. The events directory was used for the snapshot storage and the event store. You see now there is a directory called default. If I take a look in the default directory, you'll see pre-allocated files for the event store and the snapshots. In the data directory, we see the file with the process ID, not very useful because it's running in Docker. So the process ID will be 1, but also the log file. That is something now that will be available to us and will also persist overruns, and the control database. So let me run the quick tester again just to check that everything is still there and working. And I'm saying everything is still there, but of course, compared to the last run, what won't be there will be those 2 events. Because the last run we ran it with temporary volumes and they have been cleaned up. But that is no longer the case. We now can do this. And if we stop AxonServer and start it again, these same events will still be there. So to continue, we can use access control and TLS. Access control enforces the user accounts. I've already shown you the tab in AxonServer where you can define users. But you didn't need to log in to see that. If access control is on, then a login is required. For standard edition, we use a token. The token is used both for the CLI and also for client applications. and it will be the same token. For Enterprise Edition, we actually have 3 different kinds of tokens. There is a system token, which is used for the CLI. There is an internal token, which is used by the Axon server nodes themselves for connecting to each other. And there are application tokens for clients. The users with Standard Edition are just normal users or admin users, whereas for Enterprise Edition, you can have several roles, and the roles can be assigned per context. So let's enable access control here. We're going to add 2 properties, put the access control enabled value to true, and then generate some token and use that. So let's go back here. Now I'm going to make use of the environment variable naming that I discussed earlier. I'm going to create an environment variable called AxonServer token. And I'm going to give it a generated name, which just for my personal preferences will be changed to lowercase. Just to show you here, this is what it looks like, and we're going to add this to the configuration. And the second thing what we'll do is add the token, of course. Like this. Now we can start Axon Server again. We'll take a look at the logs to see if it's ready. By the way, now you see that it says access control has been enabled. So it's ready. We go back now to the UI, reload it, and we need to log in. But we didn't create the user yet. So let's do that using the CLI. We need to pass the token, of course, otherwise we won't be allowed. Sorry. Well, that's not surprising, no users yet. So register a user named admin, give it a pretty obvious password, and give it the role admin. Otherwise, it's not allowed much. Okay, this is, this is a problem with my current installation. Let's do it this way. I'll shortly disable this and create the user. By the way, there are a lot of other things you can also check on the REST interface. There is an actuator that you can use to check the health it's up. So let's go back to this CLI command. Access control is disabled, so we don't need to pass the token. Okay, sorry about that intermezzo. Call it the demo effect, but now AxonServer is ready. Let's wait until the health actuator responds. Yeah, there it is. So we can go here. Now we can log in with the admin user. And here it is. So other things you can do in the UI. Here I can show you last event token. Don't mistake this for the number of events. This is actually the last token. And if I search for events in the event store, you will see there are 2 events. The first one had number 0 and the second one had number 1. So the last token is 1. There are other things you can see here. Yeah, I'll leave that to you to experiment. And we go back to here. Persistent storage. I've already shown you a bit about persistent storage with Docker. Kubernetes, of course, is built on top of Docker, so it uses the same principles. Normally, storage within a container or a pod in Kubernetes is ephemeral. If you restart the container or the pod, you don't know what the data will be. It will probably be gone. But if you use volumes, then you can bind them or mount them to directories. And then you can keep the data and get it again the second run. So for Kubernetes, this is unfortunately a little bit more complicated because there are all kinds of terms that crop up. There's a persistent volume claim, and more. And I actually read an article by one of the people connected to the Kubernetes development team who admitted that it was a bit of a mess because at a certain moment they changed their direction. The persistent volumes, you should see them as volumes provided by the same people who provide the Kubernetes cluster. So that is what is available. The persistent volume claim is what a pod can claim from a persistent volume. However, the persistent volume will be a one-on-one connecting to the persistent volume claim. So if you don't claim all the space, then that's just too bad, but nothing will be used beyond your claim. A volume claim template is what is used for stateful sets, because a stateful set is a pod with an associated volume or group of volumes. That means that this stateful set will instantiate pods and then instantiate the associated persistent volume claims. So it's a template for generating claims. The newer versions of Kubernetes also know provisioners and storage classes. And they actually go towards the cloud providers or infrastructure providers. They are descriptions of the available types of disks and the available types of storage that you can use from your Kubernetes cluster. For example, with GCE, you can use a disk and you can actually make a persistence volume claim refer to a GCE disk. If you run AxonServer in Kubernetes, it will be a stateful service because we want the event store to be persistent and across restarts and across updates. So if we roll out a new version of AxonServer, we don't care much about the process ID, but we do care that the control DB and the event store will be available. And I already talked about the persistent volume claims that Kubernetes will generate based on the claim templates. In Kubernetes, the configuration files are not generally provided to applications as simple files in a volume. What you use is a config map that becomes an entire volume actually. So a config map sounds like a name value pair collection that you might compare to a properties file, but actually every entry is a file. So for AxonServer, we can have the AxonServer properties file, and that will be a single entry with that name in a config map. If you want to make the config map somewhat less accessible, then you use a secret. The secret is not completely invisible, but it's a lot better protected because it cannot be referenced from outside the same namespace. So let's go and switch from Docker to Kubernetes. I'm going to now run AxonServer in Kubernetes using the files from the Running Axon Server repository. So first, let me stop the Docker container. Here in the repository, you will find a README with some explanation and also the YAML file that is the descriptor. This is just a basic descriptor for AxonServer, and it will describe the ports 8124, 8024. It will describe the volume mounts. It also defines readiness probes and liveness probes, which Kubernetes use for the automated restarting. And of course, the volume claim templates for the events store and the data directory. In the same file, we also have services, which you can compare with the -p options for the Docker command, because if you only start the container, you will not be able to reach it. With Kubernetes, you have to define a service for that. So let's go to the command line. I have here Kubernetes running with Docker desktop. Here you see Docker desktop. So let's create a namespace. We'll call that test SE. And then deploy AxonServer to it by using the provided file to this namespace. As you see, this creates 3 items in the namespace. We can use kubectl to take a look at what the status is. And here you see at the bottom the stateful set itself. It knows it needs to have 1 instance, that is the default, and 0 of them are ready at this moment. There are the 2 services. One of them is for port 8124 and the other one is for 8024. That one actually is defined as a service of type load balancer, so it will be accessible. The single pod gets an automatic name, which is the same name as the stateful set, a dash, and then a number starting at 0. So let's check. Ready. All of them are ready. So that means I should be able, again, to open the UI. Now you see that it has node name AxonServer 0, which it takes from the pod name, and host name the same. This all looks exactly the same as before. Biggest difference now is it's running in Kubernetes. If we want to run the same test application, we can run it locally if we had a service expose port 8124 to localhost, but that is not something that you normally are able to do for a gRPC port easily. The load balancer service for Docker Desktop works, but it works without giving you a real load balancer. If you have a cluster of several nodes providing the HTTP service, then you won't even have the affinity, the client affinity here possibility. In this case, what we'll do is we'll deploy within Kubernetes the test application and let it run there. And just a second, let me copy that from the slide. Let's do it like this. Let me see here. I already prepared. I'm better prepared than I thought. So here's run test. Let me show that to you. It does a kubectl run, and it shows the output. It goes to the namespace. We use the same cleanup option here. We have a public quick test image that we're here using, and we pass it some parameters. The first one is, of course, the parameter for AxonServer, and then, of course, the Spring profile and the delay, the same settings we used locally. So let's run it. I have to tell it the name of the namespace. Okay, there is a bit more logging here that has to do with an option that I put in an environment variable that is not in this command, or for the logging of these specific classes. But in the end, you see the same handle command and then handle event. And if I run it a second time, it will work and we will get 2 events. So let's go back to the slides here and continue. Because now that we have Kubernetes, let's take a look at a cluster with AxonServer Enterprise Edition. AxonServer Enterprise Edition uses multiple nodes to share the messaging load, and it also makes sure that every copy of AxonServer, every node, has a full copy of the event store. The event store is replicated using the Raft protocol. If you're interested in that, a link to the Raft protocol is in a later slide. And you also can have more than just the default context. So you can have multiple contexts which are completely independent. So a client application running on a different context will not get a replay from the events of the other context. Also, because we use the Raft protocol, the cluster will keep working as long as a majority of the nodes are available, which is an extra feature for availability. In a specific context, nodes can have a role. So we can have different roles for nodes. And we also have a lot more information about security. Users and applications can have roles. On the operations side, what changes is that we now have an extra port, the port 8224, which is also used with gRPC and which is used by the nodes to communicate between each other. They use a pseudo context called admin with an underscore, which is the context where the cluster structure is maintained. So here we have the URL to the Raft protocol, if you're interested. Because we distribute the data, we also need an extra volume for the replication log, the changes that are still being sent to other nodes. Data in the replication log will be eventually stored in the event store as soon as the information is confirmed by at least half of the nodes. Another change that we need to take care of is the license file. So we need to create a secret for that. And of course, a system token if we're going to enable access control. Multiple contexts. This has some impact in the way AxonServer works, because initially when you start AxonServer, it has no context. The reason is that an AxonServer node doesn't know if it's going to be the beginning of a new cluster or it's going to be added to an existing cluster. If you want to have a new cluster, you have to initialize it there. It will then create the default and the admin contexts, although that is configurable apart from the admin context. Since 4.4, we also have replication groups. So not every context is immediately as a separate entity replicated to other nodes. Rather, you can have multiple contexts in one replication group, and the replication groups are replicated to other nodes. We have roles. A node can just be available for messaging only. Then if it does have an event store, it can be a primary or a secondary node. This is a new feature in 4.4 for tiered storage. The idea is that if you only have a primary node or only have primary nodes in a context, then all the nodes will have a complete copy of the event store. If you have primary and secondary nodes, then the primary node will contain only the newest events, and it's configurable how far into history it keeps. And the older events will be available from a secondary node. The effect is that you can use faster and more expensive hardware for the primary nodes and use cheaper disk space for the secondary nodes, because you can conceivably expect less usage of those older events. Then there is also a possibility for having a node which has an event store but does not use or join in the messaging functionality. Those are the active backup and the passive backup nodes. The usual usage for these nodes is to have a backup of the event store, and you can, for example, deploy them in a different region for disaster recovery. The active backup nodes will be joining into the Raft transactions. So they need to confirm that at least half of the active backup nodes have the event before the event is marked as committed, whereas passive backup nodes will get the event as soon as possible, but the cluster won't wait for the confirmation. Because this requires us to initialize a node or a group of nodes, we have two ways to automate it. The auto-clustering is the simplest version. Auto-clustering assigns one of the nodes as the first and a list of contexts that all nodes want to join as primary. This is a quick and easy configuration. The effect is that the node compares its own host name and domain with the first entry. If they are the same, and this is the first time the node is starting, then it will immediately create the admin context and all the other optional context mentions. And the other nodes see that their own host name is different, and they will try to contact the first node, wait until it responds, and then join it, and then join all contexts specified. This is especially useful if you have the stateful set, where if you scale it up to more than one node, all the nodes will have the same configuration. And you can use auto-clustering to make sure that it makes no difference whether or not you're scaling up for the first time or have scaled down for maintenance and then are scaling up again. The node will check, am I already initialized? And if not, then it will, and otherwise it will simply use the available data. New in 4.4 is that we also have a cluster template, which allows additionally to configure specific joining of nodes into replication groups and in specific contexts, and also the role there, where it will also allow you to predefine applications and predefine users. And where this is very useful if you have, for example, a test environment where you work out how you want to set up the cluster in production, you can use that to define the template and then use the production installation with the template to ensure that all the applications, all the client applications are immediately known and immediately have a known token and a known role. So let's go and deploy. Given the time, I'm going to skip a small part here. Let's start by deleting the namespace we had for standard edition. So need to wait until everything is removed. Here we are. We're going to create a new namespace. Now, what I initially, if there was enough time, wanted to show is that there are two ways with Docker Desktop and the embedded Kubernetes to expose services. We're going to skip the load balancer and go immediately to the ingress. This is also, the information for this is available in the README files in the repository, so you can check it there. We start by creating an ingress controller. Then we're going to create the config map and secrets. There's a script in here. This is all in the repository, so you can take a look there and have a look how that's done. Then we can deploy AxonServer itself. This time split up in two files. This is for the stateful set. And the other one is for the services, this time using an ingress. Okay, as you can see, everything is here. The difference now you see, because we don't have a load balancer, it does not say that it's exposed to localhost. I don't know if you can hear it, but my laptop is starting to ask for some fresh air. Ah, there it's coming. Okay. Okay, it's restarting, sorry. That looks like something is wrong. This all looks good. With space in here. Okay. This looks good. Let's check. Now, because we're using an ingress controller, it's exposing to a host name called AxonServer, which I have defined locally here on my laptop. Here we are. You see, this is a lot more complex. We have a lot more options here. The same last event. Now we have the possibility for more contexts. I can show you that here. I can add contexts here if I want. Node name is again the same. And if I look to the overview, you now see mention of the admin context here and the default context. So users, let's create that same admin user. So now what we can do is enable access control. For Kubernetes, this means I have to update the config map. There are several ways you can do that. One of them is to simply delete the current config map and then create a new one. In this case, I created producing YAML output using the dry run option, and then use that as the file to replace the existing config map. So let's run this. And now we must restart AxonServer. We do that by deleting the pod, because Kubernetes, in contrast to Docker, will look at the liveness, and it will, if you use a deployment or a stateful set, it will automatically restart pods. It has been deleted. Let's see. Starting up again. I'm afraid my laptop is a bit complaining about the heat. Again, this causes a few restarts here. My apologies. So, last thing I want to show you, and we'll let it run for a while, is to scale this up to 3 replicas. And while it is doing its best, I can discuss Helm. For those of you who don't know Helm, Helm is a very popular application for deploying applications on Kubernetes. It is especially useful if for a single application you need a set of different containers or need several deployments of things like config maps and containers. It will use a simple values file with a lot of comments in there that you can easily configure. Choose only the values that you want to set, and then it will fill in these values into the deployment files and restart the application. Helm version 2 still required the installation of a super user tiller into the cluster. Helm version 3 uses the client capabilities, so everything is done using kubectl commands and works completely remote. So let's see if this is now where we want it. Yes, it's up and running. So let's go here. Ooh. Log in. And what I wanted to show you here is that we can now use the scale command on the stateful set. And it will now start 2 extra nodes, and they will immediately show up here on the dashboard. It's now starting the first one. While this is running, maybe we can take some questions. Let's see. The workarounds for the community edition users to make persistent storage highly available. The high availability of the storage itself is of course something that you can also deal with the cloud provider or the infrastructure provider that you are using. However, that means you have to make backups or use a highly available disk type of that provider. So what you don't get is the shared usage of the shared messaging by multiple nodes, and there is no automatic failover. So if your AxonServer instance fails, you have to get that copy and restart it. If you have a cluster of 3 nodes and one of them goes down, then the other 2 will pick up the work. Is that sufficient answer for your question, Sajiva? So, by the way, in the dashboard here, you can see that now the 2nd node is available and he's working on the 3rd node. Due to the auto cluster options, the new nodes automatically contact the 1st node and will join the admin and default contexts. Sorry, you have to forgive my laptop. It is not happy about this Kubernetes cluster. It's a bit cramped in this system. So for AxonServer, last slide is about the Helm chart. We have no standard Helm charts which are on the official Helm repositories, but there is an example Helm chart for AxonServer Standard Edition. And the only caveat I have there is with ingress controllers and load balancers, because my experience is that is very much dependent on who the provider is of your Kubernetes cluster. So another question I see coming in here from Leo Tang. Any plans to make cluster templates so that it can be used to update or configure existing clusters? No plans yet, but it's a very good question. Generally, if you want to update or configure an existing cluster, then you already can do that using the REST interface or the CLI or via the UI. So the basic idea behind the cluster templates was to have a quick and a clean way to install a new cluster given an existing cluster. So we haven't made plans to extend the cluster template towards updating or configuring existing clusters. We can make a story of this on the board, and we'll keep this in mind. I see another question here about throttling options available for replication groups, cap the amount of throughput, noisy neighbor problem. We do have some throttling options there, but that's a bit detailed to go into here. And I'd like to ask some feedback from colleagues. So we'll write this one down and get back to you on this one. Okay, Leo, I'm getting a message from one of my colleagues that somebody's already working on an answer for you. So we have a small survey. Please take the time. I'm told it's a very quick survey, so please take the time and help us with some feedback there. And if there aren't any other questions that we can pick up now, then I think this is the end of today's webinar. I hope you found it interesting. If you have any more questions that you come up later, just send a message or pose a question on the Axon Framework forum, or send an email and we'll get back to you on it.